Alright, so in this lesson we're still looking at quadratic functions, but this time we're going to be looking at standard form instead of vertex form. Alright, so we're going to be figuring out how do I graph when given standard form, so I cannot do transformations anymore. I have to figure out a different way to graph. So make sure you're ready to take notes. These notes are going to be very important on graphing, and here we go. Alright, so everything you really need to know is right here on this paper. So all of this information is very important. This is our standard form, right? ax squared plus bx plus c. Now a obviously cannot be 0 because then we would not have a quadratic anymore. We'd have a linear equation. Now the coefficients a, b, and c tell us some very key information about the graph of my parabola here. As always, just like in vertex form, our a tells me if I'm going to open up. If it's positive, it's going to open up. If it's negative, it's going to open down. Now, since I don't have vertex form anymore to tell me where my vertex is, how I find my vertex is this right here. X here is negative b over 2a. Y is f of negative b over 2a, and we're going to get to what that means in just a second here. Now remember, our axis of symmetry is always the x coordinate of my vertex, so that's exactly what it is here. X equals negative b over 2a. And our y-intercept is still, think about y-intercept. Y-intercept is what happens whenever x equals 0, right? So if I plug in x equals 0, I'm going to get c. So that's going to be a nifty point if we can use it to graph. Alright, so now we're going to talk about what f of negative b over 2a means. Alright, so what in the world do I mean when I say f of negative b over 2a? So hopefully you recall our function notation that we learned, which was here. Like if f of x equals 3x plus 4, and I actually define f of 2, what that really means is let's plug in 2 for x. So everywhere I see an x, I plug in a 2. And then I go ahead and simplify, right? So I would say f of 2 was 10. Well, same thing goes here. What we're going to do is find negative b over 2a. Well, remember, b is the coefficient of our linear term, our x term. A is the coefficient of our quadratic term, which is our x squared term. We're going to plug in those values. We're going to find a number. We're going to take that same number and we're going to plug it back into our function, and that's going to give us the y-coordinate of our vertex. Alright, so lots of evaluating to do, but it's not too hard. Alright, so you just have to remember negative b over 2a, and then you plug it back in to find the y-coordinate. Alright, so this is another fantastic slide for you to make sure that you have somewhere in your notes. Alright, this is our go-to guide for graphing a quadratic function. So whenever we don't have our function in vertex form, this is how we want to go about graphing. Alright, so you need to write this down. So let's go through step by step. First step is to identify A, B, and C. Make sure these guys are lined up properly, right? So if they're out of order, put them in order. And then make sure you know which each one is. Make sure you're taking the sign, right? You need to make sure you use the sign that's in front of the coefficients. The next step is going to be draw our AOS on our coordinate plane, right? Now remember, our AOS has the equation x equals negative b over 2a. Then we are going to plot our vertex. So we take our negative b over 2a. That's our x-coordinate. We plug that guy back into our function and we find our y-coordinate. We're going to go ahead and plot that point, which should sit on our AOS, right? It goes right through the x-coordinate. Now, this is the part that you have a little leeway. You need to go ahead and pick 2 additional points that are to the left or to the right of the vertex. Alright, I suggest you pick points close to the vertex. So if my vertex is at x equals 2, 1, well then let's pick maybe 3 and find out what the y-coordinate is. Alright, or let's pick 4 and find out what the y-coordinate is. Let's not pick giant numbers. Alright, so you pick numbers close to your vertex. You plug those guys into your function, and then you get your y-coordinate. So in essence, we're making a t-chart here, but we're just picking strategic points that are near our vertex. Now we only need to pick 2 points on either side of the AOS, because now what we're going to do with those 2 points is we're going to reflect them across our AOS, and that way we end up with 5 total points. So you should have 5 total points whenever you're graphing a parabola. Alright, now of course you can go ahead and use your y-intercept if it's easy to graph. Now sometimes it's a big number, so you might not want to use it, but if it's an easy number you can use that. That's 0, c. Then you go ahead and you check to confirm that you are opening in the correct direction. So you go ahead and look back at A, make sure A is positive, you're going up, A is negative, you're going down. You're going to label all your necessary stuff, right? So you label your 5 points, you label your AOS, your axis, your function, everything's perfect. And then, voila, we have a beautiful, wonderful graph of a parabola. Alright, so let's go ahead and graph this guy. So I need to know what A, B, and C are first. So A, you can see here is -2. B is going to be +2. And C is going to be -5. Okay, that I just found from here, here, and here. And notice it was already in order. You need to make sure that it's quadratic, linear, constant term. Now I need to find and graph my AOS. Well, remember the AOS is always x equals a -b/2a. But I know what A and B are, right? So I'm going to plug in. I've got -2 over 2 times A, and A is -2. So that's going to simplify and give me a +1/2. So x equals 1/2 is going to be my AOS. So I'm going to go ahead and graph that guy on my coordinate plane. Okay, and then you want to label him. X equals 1/2. Go ahead and label my axes just because I'm here. Alright, now I want to find and plot my vertex. Well, the vertex exists at -b/2a, which we just found was 1/2. And then f of -b/2a, so I have to take 1/2 and plug it into my function. So that's going to be y equals -2 times 1/2 squared plus 2 times 1/2 minus 5. Getting our exercise with our fractions here. So 1/2 squared is 1/4 times -2 is going to be -1/2. 2 times 1/2 is 1 minus 5. Now order of operations left to right, right? So -1/2 plus 1 is a +1/2. +1/2 minus 5 is the same as saying +1/2 minus 10/2, which is a -9/2, which is -4.5. So I'm going to go ahead and plot that guy. 1/2, -9/2. 1, 2, 3, 4.5. This is why you always need to make sure that you are labeling your coordinates so that I see exactly what you mean for your point to be. Alright, so now that I have that, I'm going to pick 2 additional points to the left and to the right of my parabola. Now, I think it might be easy to plug in 1 and 2, so that's what I'm going to do. I'm going to plug in x equals 1 and x equals 2. So plugging in 1, I get -2 times 1 squared plus 2 times 1 minus 5. And I'm going to get, let's say, I get 1 squared, which is 1, times -2, which is -2, plus 2. So -2 plus 2 is 0. And then -5, so 1, -5. That's my y value there. So 1, -5. So I'm going to go ahead and plot that. 1, 1, 2, 3, 4, 5. It's going to be right there. Don't forget that guy's reflected across my axis of symmetry. He is a half away, so then I go a half away the other way. So that is 0, -5, which is my y-intercept, by the way, which makes sense. Now plugging in my 2, -2 times 2 squared plus 2 times 2 minus 5. So that's going to be 4 times -2, which is -8. Plus 4, so -8 plus 4 is -4 minus 5, which is -9. Can't see that, right? -9. So 2, -9. 2, -9, which I've already written on. Let me move that guy out of the way. Write it up here. 2, -9. reflected, that guy is a 1.5 away, so half and then 1 away this way. That's going to be -1, -9. And there we go. There's my parabola. Go ahead and draw it. Now I want you to notice that my A was negative and I am in fact facing down. Right? I've got all my points labeled. I got my axis of symmetry labeled. I got my X and Y axis labeled, and I'm good to go. Alright, so let's give this one a go. Extra practice, right? So let's figure out what A, B, and C are. A is 1. B is 2. C is 3. My AOS is going to occur at X equals negative B over 2A. So that's going to be X equals 2 over 2 times 1, which is going to simplify to -1. So I'm going to go ahead and graph that guy. So X equals -1. That's my AOS. Okay. So now I need my vertex, which remember happens at -1 comma f of negative b over 2a. So I need to plug in. So y equals -1 squared plus 2 times -1 plus 3. So that's 1 minus 2 plus 3. 1 minus 2 is -1 plus 3 equals a positive 2. So my vertex is at -1, positive 2. Okay. Now I need points on either side of my vertex. Well, I'm going to go ahead and pick easy points. So I'm going to pick 0. And I'm going to pick 1. So plugging in 0, 0 squared plus 2 times 0 plus 3 is going to leave me with 3 for my y. And then plugging in 1, 1 squared plus 2 times 1 plus 3 is going to leave me with 1 plus 2 plus 3. So that's going to leave me with 6. So go ahead and graph those guys. 0, 3. And then I have 1, 6. Now remember, I have the reflection of those points across my AOS. So altogether I have my 5 points. I'm going to go ahead and draw the parabola. Label my X and Y axes. Need to label these guys also, so that's going to be -2, 3. That's going to be -3, 6. Notice how they have the same Y coordinate. And that looks like I'm done. Alright, now obviously I can't have you graph on a Google form, so I want you to go ahead and find all this information for me and put it in your Google form. Alright, so make sure you're looking at your notes. And I also want you to find 4 additional points that are going to be on the parabola. Now remember, you could find 2 and then find the reflection points. Alright, and make sure you label everything correctly in your Google form.